Hello student, today we are going to solve the second problem of revision series. So what we are going to do is doing a simple problem of thermodynamics, but this problem involves the polytropic process. So there's two ways to solve this problem. First, you should pause the video and try to do this problem by yourself. As the problem state, an amount of heat Q is supplied to 1 mole of diatomic gas undergoing a process such that volume is directly proportional to a positive constant upon T square. If the temperature increase from T to 3T naught, then find the heat supplied during the process. Your options are 2RT naught, 4RT naught, 5RT naught and RT naught. Maximum time to solve this problem is 3 minutes. So try to solve this problem in 3 minutes and then try to match the solution that you are doing the problem in the right way or the wrong way. So you should pause the video. You must pause the video because this is a very important concept involving all the thermodynamics done from the polytropic process. So this problem can be solved from the multiple ways. You should try to solve this problem and get the right answer. Getting the right answer in the revision series is very important so that you can at least judge your concept. So pause the video and when you solve this problem, then continue with the video. Must watch the solution because I am going to do this solution from the two ways. The two ways is possible. Okay, so pause the video and try to solve this problem. So student, are you able to solve this problem by yourself? There is the two methods. One is direct method and second is indirect method. So first we are going to start the problem with the what is given in the process, what is given in the question, what is information is provided in the question, because in the thermodynamics we always have to judge the problem by the language what is given in the problem. So given in the problem is 1 molar gas, that is also the diatomic gas. Degree of freedom of diatomic gas will be 5, 3 will be translatory and 2 will be on the rotation side. The relation of volume with temperature is given and temperature is changing from T naught to 3T naught, and we have to find the heat transfer or heat of the process. This is a cyclic process. So there are direct approach to find the heat and there is indirect approach. As you know that heat is first law of thermodynamics, delta U plus work done. This is the first law of thermodynamics. First law of thermodynamics. So we can see that heat is summation of change in internal energy and the work done by the gas, and it also can be written as NC dt of any process. We can say that any process, it is true for any process. So if we go from the direct approach, so the approach 1, we try to find the heat from the NC dt, and that the indirect approach we try to find del U and the work done of the process, and then we try to sum the quantities and find Q. So first we are going to look at the first approach, direct approach, that is very fast approach and it is also applicable, and we are going to talk about the polytropic process, how the polytropic process, because this relation is not a normal process. This relation is not isochoric, isobaric and isothermal and adiabatic process. This is a polytropic process which we are going to study right here, and this is the basic application of the polytropic process. So we are going to study the problem and giving the solution of the problem from a two approach. So start with the direct approach, the approach now. And we are going to do the problem from a direct approach. That direct approach is going to involve the formula Q equal to NC dt. We are going to integrate that from T1 to T2. So we are going to see how we are going to do that problem. So our relation, what was given in our relation, that V is equal to positive constant upon absolute temperature to power of 2. So we are going to take this temperature to the left hand side and multiply with the volume. So that relation can we easily see will be turned out to be this: volume into temperature to power of 2 equal to positive constant or positive constant, we can say it. So this is the constant, we can assume this is a constant, we can assume. And after taking the square root of the equation from to the left hand side and the right hand side, the right hand side will be the constant and the left hand side will be the V2 to the power 1 by 2 into temperature. So we're going to compare that equation with the Poitovich equation in the form of temperature and the volume. So we can get that equation from the Poitovich equation: PV to power n equal to constant. So if we put that P in that equation, to P directly proportional to temperature and the volume, then we can say that we will get the equation T into V to power n minus 1 equal to constant. So we can compare these two equations and we can see the value of n will be n minus 1 equal to 1 by 2. This equation we will get, and after that getting this equation we can say the n value will be 3 by 2. When the n value is 3 by 2 and we already get the value of n, then we can easily find the value of specific heat for the process. What will be the specific heat of the process? The C, this is the basic formula. A specific heat of the process, C equal to Cv plus R upon 1 minus n. If we put n the value, what we get 3 by 2 from the equation, comparing the equation with the Poitovich equation. So we will get Cv plus R upon 1 minus 3 by 2. The Cv is also represented from the degree of freedom, as we can see from the kinetic theory of the gases, F by 2 into R. So we are going to do these two equations and put in that third equation, F by 2 into R plus R upon 1 minus 3 by 2. So that will be 5 by 2 R minus 2R, that will be R by 2. So we will get the this Poitovich equation specific heat, that will be C R by 2, and that we are going to use in the formula of the heat. So we can solve this problem from the direct approach. That approach will be dq equal to nc dt. So we're going to integrate that from t1 to t2 and find the value of q. So the n will be multiplied, 1 will be multiplied with the c. The value of c is r by 2. That is going to integrate from the t2 minus t1. That t2 is 3t0 and t1 is t0. So we are going to get the value t0, and so the r by 2 is going to cancel the 2t, which we are going to after subtraction. So we will get the answer is rt0. That is the D option. So this is the direct approach in which we directly try to calculate the heat. We don't going from the longer approach to calculate the work done and the internal energy. We are going to do the second type. How we going to solve this problem from the second type also after this. So this is the first approach. First we get the value of n, then we get the value of c, then we get the value of q, because q is always nc dt, the c of the Poitovich process. If this were to be isobaric process, then the c will be replaced with cp, and isochloric process cv. So this is, we are going to understand that q is always nc dt in every possible process. So this is the first approach, and now we are going to do the problem from the indirect approach, the approach B. Okay, that in this approach B we already have the value of n. Well, how we get the value of n? Simply comparing that value of that equation of V and T with the respective equation of the Poitovich equation of V and T. So what is the Poitovich equation of T and V? T into V to power n minus 1 equal to constant. So if we compare the 1 minus n equal to half, n equal to 3 by 2, it is already done in the previous type of problem, like the previous method. So n, the value of n is 3 by 2 we get from comparing the Poitovich equation. Now we can get the value of q from the summation of change in internal energy and the work done. So what is the internal energy, change in internal energy, and what is the work done of the process? What we study from the kinetic theory of gases, that internal energy in all the processes is NCV dt. This N is the mole of the gas. It's not the polyatomic index, and this mole is a polyatomic index. So I'm going to put NP. So what will be a dV, du will be NCV dt. That N will be the one, that the mole into Cv is F by 2 into R, that we get from the kinetic theory of the gases, from T1 to T2 minus T1, that is the integration, then putting the limit, and F is 5 for the diatomic gas, 3 from the translation, and 2 from the rotation. That we should remember always. The 5 by 2R into 2R, that will be the 3R 3 naught. That is the change in internal energy of the process. Now we are going to get the work done for the polyatomic process. And what is the work done for the polyatomic process? The basic formula of the work done for the polyatomic process is very similar to the adiabatic process. P1 V1 minus P2 V2 upon N minus 1. In polyatomic process, what we have, upon of the ratio in gamma minus 1. Gamma is the polyatomic index, as the N is the gamma was the adiabatic index, as the N is the polyatomic index. So we can change the P1 V1 from the PV equal to nRT. PV equal to nRT. This N is polyatomic index. This N is polyatomic index. You should remember always, because in this equation we are using N as the mole, and in that equation we are using as the index. So what we did, that we get the polyatomic index, and NP is 3 by 2. So we're going to put this equation, change this equation P1 V1 into temperature, and then we are going to put T1. T1 is T naught and T2 is 3 T naught. So we are going to put and 3 T naught minus 1. That will be 3 T naught minus 1, that will be half, and when that half goes on the upper side, that will be 4 RT naught. So the work will be the minus 4 RT naught. We have to always take the sign in the thermodynamics, and when we are going to add those signs will be du plus dw, the 5 RT naught which we get from the NCV dt, and the minus 4 RT naught which we get from P1 V1 minus P2 V2 upon N minus 1, or and T2 minus T1 upon N minus R. So the value of the Q will be R T naught. This is the indirect approach. This is not direct approach. If we get the value of N, then we try the value of C, and we can get the heat. And if we have value of C, then we can get work done, and dV, then we can get the value of Q. So those are the processes which we can do. This is a direct process, A process, this is P process. So this is the whole theory involving the polyatomic process, how we can get the heat of the polyatomic process from the work done on internal energy, or directly from the specific heat of the polyatomic process. Okay, thank you. Watch this video and other video. Also like, share and subscribe this video for other questions in the revision series. Thank you.